Hi everyone, I'm Thomas Pesquet and I'm with my favorite astronaut, Shane Kimbrough, up here on the space station. Today we're going to talk about a very cool new NASA mission. It's called DART. Can you tell us and tell me a little bit more about what is NASA's DART mission and what does NASA DART mission stand for?
Okay, yeah, so DART is NASA's first planetary defense test. So we're gonna try to do something we've never done before with the spacecraft. DART stands for Double Asteroid Redirection Test. So a nice acronym. NASA does like acronyms. DART is another one. Now the purpose of this spacecraft and this mission, it has one purpose, and that's to crash itself into an asteroid and try to redirect it or try to move it into a different orbit.
So today, Shane, we're gonna demonstrate some of those principles that you laid out before, but can you tell us exactly how we're gonna do that?
Well, I can try. It's the first time for us, but we're gonna try to demonstrate this asteroid kinetic deflection method, which is really the moment that spacecraft crashes into the asteroid. So we're gonna use microgravity up here because we have that all the time. And we're gonna try to show you kind of how this is gonna work when the asteroid is hit by this spacecraft called DART. So here we go.
So what I'll do, Shane is going to be the asteroid, and I'm going to be the NASA DART mission. Or this CTB, more exactly, is going to be the spacecraft. I'm going to try to throw it, and we'll look at the effect of that mass coming at him and the kinetic energy transfer from the CTB to Shane. Shane will be perfectly stable. It's not an easy task. You ready? All right, here it comes. I've redirected Shane successfully. Pretty good. A while ago, we got out the door and we got some new solar arrays here on the space station.
And so the same technology we have here now on the space station is going to be used to power the DART mission on its way to this asteroid.
ROSA, in case you didn't know, but you knew, it stands for ISS Rollout Solar Arrays.
So we got a chance to go outside and install the very first two of these new IROSAs, or Rollout Solar Arrays, on the very end of the space station, out on the port side. These are different because, for one, they're much lighter and smaller. To me, they look very fragile when we were picking them up and moving them, but they're rolled up. So when they launch, they're kind of rolled up into a compact cylinder, which is great for launch conditions. And then once they get up on the space station or in space for a satellite or something, they can then roll these things out to be useful. And so the same technology we have here now on the space station is going to be used to power the DART mission on its way to crashing into an asteroid.